In Unit 2, Learning Set 8, you're going to learn about the present value of investments. And what this means is sometimes we know, for example, like we want to go on a trip in 5 years, and maybe it's a trip to Europe, and you need to have a certain amount of money to be able to take that trip to Europe. So we want to know how much money am I going to have to put into an account so that I earn enough interest and save enough money to be able to go on that trip in 5 years to Europe. And this is where the present value of investment formulas come in. And the objectives for this lesson is to calculate the present value of a single deposit and calculate the present value of a periodic deposit. So single deposit means you put money in once. Periodic means you put money in each compounding period. Okay, so let's look at the first one. In this first video, we're going to look at just dealing with finding what single deposit we need to put in. So same as usual, B represents the ending balance. P represents the principal or the original balance that you are putting in once. R is your annual rate expressed as a decimal. N is how many times is your interest going to be compounded. And T is the number of years. So to derive this formula of a single deposit, we are going to use the compound interest formula because that is when we put money in only once. And from this, we're going to basically isolate the P because in this situation for the future value, we know what we want our end balance to be. We just don't know what our P should be. So in this case, what you're going to have to do is you're going to have to move 1 plus R over N to the NT to the other side of the equation. So you would divide both sides by 1 plus R over N to the NT, and it would cancel out on the right side, and you would be left with the formula P equals B divided by 1 plus R divided by N to the NT. And that is the formula that we would use to determine what single deposit we would need to put in to reach a certain amount of money. So in this first example, Mr. and Mrs. Johnson know that in 6 years, so that's our time frame, 6 years, their daughter Anne will attend state college. She will need about $20,000. So this is what our end balance needs to be for the first year's tuition. How much should they deposit into an account that yields 5% interest, that's our rate, compounded annually, so that means our N equals 1 in order to have that amount. So we would put in 20,000 for our B, 0.05 for our 5%. We're compounding it once, and then our time frame is going to be 6 years. So using the formula we derived to find the present value, so what is the principal amount we need to put in, we are going to fill in the formula, 20,000 divided by 1 plus 0.05 divided by 1 times 6. Don't forget, if you're doing this on a calculator, you need to put parentheses around the whole bottom so that it forces that to calculate before 20,000 is divided by it. And we end up with 14,924.30793. Remember, we're looking at money, so if they don't tell us to round it to the nearest dollars, in this case, they did tell us to round our answer to the nearest $1,000. So that means we're not looking at cents like we normally would. We actually want to round it to the nearest $1,000. So we need to look at the number after it. So it is a 9, which tells us we need to round the 4 up to 5. They will need to deposit $15,000. How many years would it take for $10,000 to grow to $20,000 in the same account? All right, so looking at this, we're going to have to kind of do a plug and check. So we're going to need to check different values of t to determine when 10,000 would grow to 20,000. So we would use the filled-in formula from the previous example. The only thing we would need to do is replace the t value of 6. So I'm going to start off with replacing t with 10 years. And that means in my formula, I'm going to replace this 6 with 10. And I want to see how close is it getting me to that present value of $10,000 that I want to start with. And in this case, when I solve it, it's $12,278.27. So it is not quite there yet. So I'm going to jump up to 15 years. And when we put in 15 years for t, so remember, that's where we're replacing it right here. We're going to change the t to 15 years and solve it out. We get $9,620.34. So now we're a little lower than our 10,000 that we want to put in to begin with. So our next step is I'm just going to go back 1 year and see how close I get. And let's go back and use 14 years. And when we plug it in and change the years to 14, we end up with $10,101.36. Now, I know that at 15 years that 9,000 is close, but they want to end with 20,000, and if we end with 20,000, and if we put in this 9,620, that doesn't match the 10,000 they want to put in. So by using the 14 years, we're close. So our answer would be approximately 14 years. In example 2, Ritika just graduated from college. She wants $100,000 in her savings account after 10 years. So if she wants that amount in her savings account, that is what her ending balance that she wants to have. After 10 years is our time. How much must she deposit in that account now? So the way they're stating that deposit now, that means they're looking at a one-time deposit. So they want to know what the principal needs to be at a 3.8% interest rate, compounded daily. So that would be 365 would be in order to meet that goal. Round up to the nearest dollar. So our ending balance we want is 100,000. Our rate is 3.8% or 0.038 in decimal form. We're compounding daily, so n is 365. And our time frame is 10 years. So we're going to take our future value for a single deposit formula, plug in our amounts, and we end up with $68,387 and 0.49359. Now, they said round to the nearest dollar. So that means we're looking at the 7, we're looking at this, and after it. So the 4 tells us it just stays the same. So she would need approximately $68,387. So how does the equation from example 2 change if the interest is compounded weekly? So basically, everything is going to remain the same except the n. Because if it is compounded weekly, that means our n is now going to equal 52. The interest is now compounded 52 times a year. The other thing that will happen is if the interest is compounded less often, before it was 365 days is the number of times it was compounded. that means you aren't going to end up earning quite the same amount of interest.